Oh, oh, is it working? Is it working? I don't know. I don't know if it's working. This is the first time streaming on YouTube. Let's see how this goes. Um, how do I YouTube? Asking for folks' patience while I sort out how this works. Pardon the delay. Please allow a moment while I figure out how computers work. Oh, look at that. Oh, so fancy. All right. So in that case, Saturday Hangouts. Pardon the delay. Please allow a moment while I figure out how computers work. Oh, look at that. Oh, so fancy. All right. So in that case. All right. So it's not going to be the smoothest recording, but that's okay. Oh, why don't I have audio? Oh, come on. Come on, come on. Oh, okay. Test 1, 2. Okay, that does not seem to be working. Test 1, 2. Oh, okay. It looks like OBS. Oh, no. I think I have output. I don't know. We're going to see. So then. All right. Test 1, 2. Weird though. So, real quick, I shared a link to YouTube in Discord. Can someone check and see if the audio is working? Yeah. Alternatively, can I just? Oh, I can see the chat here. Yeah. Can you hear me? I'm just going to keep making noise until someone confirms. Making noise. Yeah, you can hear? All right. Cool. Thank you guys for checking. Oh, now I'm hearing it. Oh, I'm probably hearing it from you. Okay. So let's Okay, interesting. That's more sensitive than I expected. So let's what time is it? Yeah, it's about time to start. Okay. So okay. I'm having trouble switching context here. All right, so hello everyone. Welcome. We're gonna get started now. If you're not on the Discord, you can scan this QR code, or you can enter that link, that URL right there, if you'd like. There's a web client, there's a desktop client, there's a mobile client. It works on everything. We're also streaming on YouTube right now. I sent the link to the YouTube stream in Discord. I'll also share the slides later. I say too much. And this is our first time streaming on YouTube, so if you go back and watch the YouTube video and something is weird, please let me know so we can fix it, because we've never done it before. At least, I've never done it before. It looks like Alex maybe has, but yeah. So, I'm Beej. This is Code Soul. For those of you who may not be familiar, Code Soul is a nonprofit based in Seoul, South Korea. We do IT education and other IT community events in English in the Seoul area. Today is our Saturday Hangout session. Saturday Hangouts, we alternate between workshops and social events. This week is a workshop, hence this going on. And today's topic is going to be DevOps for Dummies. Any questions about general things before we get started? Cool. All right. So, um, wait a second. I think. Yep, I missed. So the my normal disclaimer is missing from the presentation. So sorry, but um, I'll share my normal disclaimer. I'm not a super expert in this stuff. I have not written a book on it. Um, I'm just sharing things with you that I have learned throughout my career and other experiences, and I hope that it can be helpful for you. I hope you can use this as a reference, or even better, as a launching point to go learn other more advanced things. Um, this presentation in particular was quite difficult because I wanted to go really deep into it and like do all the cool fancy things, and it was really hard to keep it at a basic level. So if I start to go too deep, be like, Beej, you're confusing me, stop. Okay? Or if I speak too quickly, because I like this stuff, I enjoy it, I get excited, I speak quickly. If I go too fast, please stop me. Okay? I have no problems being interrupted. If you have questions, all that good stuff, just go for it. All good? All right, enough pontificating. Let's go. So, today we're going to cover some of the basics of DevOps. We're going to cover what is DevOps, along with some of the key parts of DevOps, including. Oh, that doesn't. There we go. Including infrastructure, continuous integration, continuous delivery, monitoring, and developer experience. If you have no familiarity with DevOps, a lot of these words will be mostly meaningless to you, and that's okay. By the end, we hope to give you some kind of understanding. Any questions about the agenda before we get started? Cool. All right, so let's go ahead and dive in. So, what is DevOps? You automate all the things. You just automate everything. If it exists, you automate it, basically. I'm exaggerating, but it's basically a combination of dev and ops. Dev, I assume you're familiar with, it's development, creating software using code. And ops, which these days is kind of a dying practice, except in the larger companies. So ops is the idea of you have technical people who don't necessarily code, but they're responsible for keeping the application up and running. They're responsible for deploying the application. They're responsible for configuring things in production and in development. They're the people who keep everything running. It's the not sexy, but really important job. But with software engineering and tooling and code becoming much, much more common, people started wondering, well, all the support work that we're doing, can't we just automate that like we automate everything else? And so DevOps was born. So DevOps is the automation of ops tasks. Sometimes it's kind of a practice. So, like throughout the company, the engineers learn the principles and ideas and skills of DevOps, and then every engineer does it. Or in some companies, you have people whose specific responsibility is to act as a DevOps engineer, where they do the DevOps work. Neither is right or wrong, it's just different ways of doing it. For example, in my current department, we kind of have an half and half. Software engineers are expected to have a little bit of understanding of DevOps things, but we also have a dedicated DevOps engineer to do the heavy lifting. And it's not like you're either doing one or the other, it's usually a spectrum. You have some combination of the two. So what kind of work does DevOps handle? Well, the agenda kind of gave it away. Mostly infrastructure, continuous integration, continuous deployment, monitoring, and developer experience, and we're going to explain all of those things today. So any questions so far about what DevOps is, or the kind of role it's meant to fulfill? So what kind of work does DevOps handle? So continuous integration is kind of how you get everyone's code to merge together and make sure things still work. And actually deployment's wrong. That should be delivery. My bad. Yeah, it's continuous delivery, not continuous deployment. Sorry. Continuous delivery is actually deploying your app in an automated an automated repeated manner. And I'm going to explain both of those in more detail. Sound good? Cool. I really want to fix that right now, but yeah, no. Other questions before going forward? All right. So, first, infrastructure. Also, I went really hard on the memes here because DevOps is a very memey. I'm going to stop with that. Okay, so usually when we talk about infrastructure, we divide it into kind of two key categories. You have cloud-based infrastructure, and you have data center-based infrastructure. Cloud-based infrastructure usually references public clouds. So if you've heard of AWS, Amazon Web Services, or GCP, Google Cloud Platform, or Microsoft Azure, these are all public clouds. And data centers are your company has rented some physical space where they install servers and they do all the wiring and all the connection. They manage the temperature, the power, all these kinds of things are managed by the company directly. DevOps can span one or both of these areas, depending on the company, depending on the need, all this kind of stuff. So, how do we automate these things? Because DevOps is all about automation. It differs. In the cloud side, we often use a tool called Terraform, which can write out our infrastructure as code. Because remember, we're automating stuff, so we're writing code. Now, Terraform is not the only way to do it. That's just my recommended way of doing it. And basically, you say, hey, I want a server. It should have these configurations. Go build it. And then the system goes and builds it for you, as opposed to you clicking around in the UI and all that kind of stuff. On the data center side, we have another tool called Ansible. It's basically a remote management tool. You define the state that a server should be in, and Ansible goes, connects to that server, and does all the stuff to make it match the state you defined in your code. Ansible and Terraform do very similar things. We're not going to go too deeply into them because sometimes infrastructure is not 100% part of DevOps. Sometimes there's a dedicated infrastructure team, but again, it depends on the company. And also, infrastructure is this whole giant area. We're only going to touch on things a little bit. And I'm hoping that we can have some extra time at the end where if you want to ask more detailed questions, we can do that. So I won't go too much more deeply into these, but when you think cloud and you want to automate cloud deployments, not deployments, you want to automate cloud infrastructure, go with Terraform. There are alternatives, but that's the one I personally recommend. If you want to do data center stuff, you can do Ansible. In terms of the kinds of problems you consider when setting up infrastructure is, cost. How do we make sure we don't cost the company all of the money? How do we make sure that things can scale, right? If we go from 200 users to 200,000, can we do that, right? Or do we expect to even do that? Monitoring, how do we know if things are running? Are the servers turned on? Did they overheat? Did the data center explode? We need to know these things. Especially, remember how Kakao a few months ago? Yeah, their data center caught fire, and everyone was like, oh yeah, I guess Kakao is down. Like, that shouldn't happen, right? And then security, right? How do we make sure that people on the internet cannot get into our stuff, steal our data, damage our services, cause general chaos? Because that's a thing people like to do. So any questions about kind of the infrastructure area? We're going to touch on a little bit more, but at a high level. So Terraform is, it's a combination of things. At the highest level, it's a way to define your infrastructure as code. So I have this network, I have these firewall rules, I have these users, I have these servers, and then there's a CL, and so that's a text file, right? And they have a CLI utility where you can, install various plugins and whatnot and say, hey, given this file that defines my infrastructure as text, talk to AWS or talk to Google or whatever and make that infrastructure happen. And the CLI parses your infrastructure as code file and then just communicates with the AWS API to build all the stuff. Does that make sense? I don't know if I call it a framework because you're not really making custom logic. You're just using it as a tool to define some state. Yeah. Yeah, it's not really a language. It has a JSON-like language that you use to define the infrastructure, but it's more like, in terms of the code, it's more like YAML or JSON, and then and then they have like predefined values of like, hey, you have this key which defines a server, you have this key which defines a network, you have this key which defines a a VPN connection or something, right? And then you have sub items that define all the various properties and so on and so forth. And then it's just a data format, right? Like JSON or CSV or whatever. And then the CLI reads that and then does a bunch of work. Does that make some sense? Cool. Yes. So you can define Kubernetes resources using Terraform. Um, and I recommend that for some things, like, for example, infrastructure that's shared by the whole cluster. So, for example, setting up the network mesh. Say you're setting up Istio on Kubernetes or something like that, or say you're setting up Nginx Ingress or something. That's something that all the applications are going to share. That's something I might define in Terraform. But then my actual software application, I'd rather define that in Helm and then have that as part of my continuous delivery stuff, and we'll talk about that later. Does that make sense? Cool. If you did not understand that, don't worry. That's a much more advanced thing. Okay. And then you had a question? So any what X is best, the answer is always going to be it depends. Yeah. Yeah. So the things it depends on are the skills that the engineers have, the scale that the company needs to meet, and the cost that the company has. So if we use AWS as an example, you have kind of four options. You can use something like Elastic Beanstalk, right? Which is like the lowest effort possible, right? But you have less control, and it can scale pretty well, but not like infinitely, and it's a bit expensive, right? And so like that's probably good for startups who have good investment money, right? Or they're so early stage and their traffic is so low that they have like one server and they can't be bothered to manage stuff, right? Um, the next step would be kind of like, and these are not necessarily sequential. Next step was not the right way to say that. Um, is kind of like setting up an auto scaling group where you set up a profile of a server. Mm. Ah, got you. So you're not asking like how to implement an auto scaling structure. You're asking how do I set my auto scaling thresholds. Um, that's that's going to depend on your traffic. Ideally, you have some kind of monitoring, which we'll talk about in a bit, so you can see your traffic patterns. And if your traffic is spiky, and it's predictable, you may just want to do like time-based stuff, right? But if your traffic is kind of like a linear growth, then doing just like a CPU threshold is fine. You can also in larger companies, I've also seen where they do um, kind of historical deviation scaling. So they say, hey, for the past 6 months at this time of day on this day of week, it's been at 200 users, but today it's at 300 users. Okay, something's weird. Let's scale up just in case, right? Um, so it kind of just depends on the business and the behavior of users, and how much time and effort the company is willing to put into it. Um, and that's also like making those decisions is kind of why we get paid, right? There's not ever going to be like a solid always answer. But does that give you an idea of the kinds of things to look out for in the different methods, or are you looking for something more? Mm, got you. So for the benefit of the stream, he was asking, right now he's doing some threshold-based scaling, and is that okay? So if it's not causing trouble for your users, and if the company is happy with the cost, whatever, man, it's fine. If the company is starting to tighten up on cost, you may want to look into kind of tighter things. But then you have to balance the cost of your time versus the cost of the infrastructure, right? Because you could do the deviation-based stuff, but I forget exactly what tools the cloud providers give. The deviation stuff might be built in and maybe it's easy, but if it's not and you have to set it up yourself, and the cost benefit might be like $100 a month, it's probably not worth it, right? So you have to do a cost benefit analysis. Does that make sense? Cool. All right, other questions? Cool. All right, so let's go forward. So just if you're completely new to all this stuff, I just dumped a list of public clouds out there. The first being like top left going down. AWS is by far the most popular. It's also one of the more expensive ones. GCP, Google Cloud Platform, is particularly good for AI and big data. And if you have more data center experience, GCP will feel a little bit more comfortable. AWS does a lot of abstraction compared to normal data center things, whereas GCP is a much closer one-to-one mapping between the data center and their cloud abstractions. Not perfect, but much better. If you want to stay with one of the big players, but you want to go cheap, Azure is the way to go. They have, especially if you're in a startup, they are working really hard to capture the startup market right now. I also have a friend who works at Microsoft Azure Korea, so if you want to do that, I can hook you up with a deal, maybe. Maybe not a deal, but I can at least get you in touch with him. And then after those are the three big ones, and after that, the popularity goes way down. Oracle Cloud Infrastructure, I've heard it's quite cheap, and it's Oracle, so like it should be good? Question mark. Linode is starting to grow. Some of these are not quite in correct order of growth. Like DigitalOcean should probably be next in terms of popularity. Actually, DigitalOcean might be a little above Linode. And then OpenStack is if you want to set up your own cloud in your data center, you can use OpenStack. It's an open source infrastructure management system. But that's way advanced. If you're here, you probably don't want to be messing with that. But OpenStack, they have a whole bunch of different public cloud providers that are smaller that use OpenStack to provide their cloud services to you. And they may have quite cheap prices. And then Rackspace, Alley Cloud, they're just kind of smaller ones. Naver Cloud and Kakao Cloud are Korea-specific ones. I'm not sure about their presence outside of Korea. But if you're working with government stuff, you may end up being forced to go with a Korean cloud provider. And from what I've looked at, it seems like they cover most of the important features, which is good because I kind of didn't expect that. In terms of quality, in terms of cost, I have no idea, but it may be worth investigating. Any questions about the public cloud providers? Any particular ones people are interested in and have questions about? So my current company uses both AWS. Well, actually, we use all three of the big ones. The research team uses, or the research division uses Google Cloud Platform because they're good for big data and AI. The product team mostly uses AWS just because that's what they're familiar with. And I have heard that we use a little bit of Azure in some kind of smaller regions that need very little compute and very low complication deployments, just because we don't have that many people that know Azure. We don't use any of the other ones currently. In the past, I've worked at companies that exclusively use AWS, exclusively use GCP. I did a brief investigation into Naver Cloud because we were working with Korean government entities at one point and could not use AWS. Yeah, does that answer your question? So the nice thing is that if you get familiar with one of them, learning the others is not so hard. So I had about 2-ish years of experience with AWS, and I went and got certification with AWS. And then my boss was like, "We need GCP too," and I'm like, "Okay, let me go learn that." So I studied for like a week, and then I went and took the test and I passed. So they're quite similar. The abstractions are different. Um, so like AWS simplifies a lot of stuff, and GCP is more like direct management of things. Well, direct, not exactly direct, but less abstraction. Um, but the concepts are still the same. It's so this meme right here, this just I don't know if would you even call this a meme? Anyway, there's no cloud, it's just somebody else's computer, right? Even all these big public cloud providers, they're just running data centers, right? So if you understand how a data center works, you can figure out how the cloud providers work. Does that make some sense? Cool. Yeah. Now, AWS also has, so we're building like a data lake, and we do a lot of AI stuff, and GCP's AI infrastructure is quite good. Yeah. AWS also has good infrastructure, but Google fits our stuff a little bit better, specifically because of their tensor processing units, which is super nice. Other questions? Cool. All right, moving forward. So if we're talking about infrastructure, we have to talk about Docker and scaling. If you don't know Docker, you got to study. Fortunately it's not terribly hard. Understanding the concept is a little bit difficult at the beginning, but once you understand the concept, the implementation is quite easy. Yeah, it's not understanding it at the beginning is not fun. You're like, what the hell is a container? But once you kind of learn to black box it, then it's quite easy. So if you're not familiar, Docker has to do with consistently reproducible environments. You define what your operating system is configured like along with the file system. And then if you run that Docker image as a container on different machines, it should behave exactly the same. Keyword should, but you know. And then Kubernetes is basically running a whole bunch of Docker containers as a cluster. And that's super complicated. That is difficult to learn, but we have a presentation on it if you want to learn about it. It's linked here. Also, when you're scaling with Docker and Kubernetes, if you're not careful, it can get really expensive really fast. You don't want to come back on a Monday morning and be like, why are we scaled up to 8,000 servers, right? You want to be a little bit careful. That said, there are alternatives. You don't have to go with the Docker Kubernetes route. You could do like virtual machines with auto scaling configuration. You could do kind of cloud managed Docker, where rather than doing Kubernetes stuff, you can just say, hey, AWS, here's some containers, do stuff with them. And all the major cloud providers have some kind of managed Docker service where you don't need to go full Kubernetes. But yeah, questions? That said, there are alternatives. You don't have to go with the Docker Kubernetes route. You could do like cool virtual machines with auto scaling configuration. So if you want to get more into infrastructure, you want to be like the infrastructure person, you want to be that guy at your company. I recommend studying Linux. You should be comfortable with Bash. You should know how the operating system works, a little bit of how the kernel works. You want to know basic networking, so like how does IP addressing work? How do address spaces work? What is NAT, network address translation? What are ports? Why do they matter? You want to know some network design. So, given some IP space, how do you allocate space to different needs? How large a space do you allocate to different needs? You need to know routing. So how do you route between networks? You should learn about VPNs because you probably want to have a VPN between your company's office and the cloud provider so that you can work over a secure connection rather than just going out over the public internet. You want to know about firewall rules, all this kind of stuff. You want to know about load balancing, especially if you want to work with large scale applications. Let's say you have a customer, like your B2C business, a business to customer business, like Cacao or something. You need to know how load balancing works. You should understand horizontal versus vertical scaling. Horizontal being just adding more servers, vertical scaling being just getting a bigger server. You should study identity and access management, IAM. That's for security purposes. How do you add new users? How do you make sure they only access what they need to access and not extra stuff that they could then do bad things with if someone stole their account info? And then configuration and secret management. So if I deploy my application, how does it get secrets from the infrastructure? Because secrets should not be embedded in your code; they should be stored in some separate system. Okay, so does that make sense of kind of like a study plan if you want to get into this? Cool. Oh no 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 no. This is the stuff you should go Google on your own time. We do not have enough time to cover all that today. Yeah. All right, so going forward, on from infrastructure into continuous integration. So maybe your team's like, tests are great, let's write some tests. And then like, hey, let's all write code together and then let's all merge our code together. But like, how do we make sure that our tests pass if everyone's writing different code and we make sure stuff kind of just works together? Continuous integration, okay? I just wanted to use the SpongeBob meme, that's all it was. So continuous integration is, this is a very simplified version. Running integration testing and reviewing before merging code. Okay? So developer A has their code, they want to merge it, they have merged it to master. Developer B wants to merge their code. How do you make sure that their two changes don't break everything? Right? Basically that. So if you're running integration testing and you're reviewing code, where do you do this, right? Well, there's a whole bunch of tools, right? Whoa, my rendering. I should fix that later. But basically, you usually it integrates with your source control system. So if you have like GitHub or GitLab or Bitbucket or whatever your Git thing is, your continuous integration tool usually integrates into that and watches when code changes happen in Git. Okay. And then the CI tool is basically just a fancy task runner. Okay. And it just watches your changes in Git. And based on your configurations, it does stuff. It doesn't even have to be testing. Okay. As we'll demonstrate in a bit. There's a whole bunch of different tools to do it. I don't know why there's so damn many. A lot of them are actually kind of terrible. But today, when we do our interactive portion, we're going to do GitHub Actions. Okay, so we're going to run with that just because that's easiest to set up and most common. I would argue it's not the best. I actually prefer some other ones, but for our purposes, it'll be easy to get going and easy to kind of show you how things work. Okay. So the way continuous integration works is basically you usually have some file in your software project that says, hey, when a pull request happens or when someone wants to merge code, execute this or execute that. Or when stuff does get merged to master or someone does a git tag, execute this. It's just a task runner. Okay. Those tasks can be running tests. They can be running linting. They can be doing like database migrations. They can be doing deployment, which we'll talk about in a little bit. All this kind of stuff. Okay. Questions so far? I have not. Honestly, like, I'm not 100% happy with any of the ones I've used. Like, each one has their own special way that they suck. But they all get the job done, right? They can all do whatever you need. I like GitLab CI the most in terms of like defining my tasks, but management of GitLab CI is a pain in the ass, right? Whereas GitHub Actions, I don't like the way that it manages multiple workflows. I want there to be more kind of dependency tracking between things, and you can do it, but I don't like the way it does it. Jenkins is surprisingly not terrible, but because it came from a no-code way, like doing everything in a UI, to a code way, there's still some weird stuff that they haven't quite figured out how to make work between the two. We used to use BuildKite. It's not very popular, but it's not bad. We tried to use Drone CI and gave up because it was just, we didn't like it. And I don't really have experience with the other ones. Does that kind of answer your question? Other questions? Yeah, I like GitLab CI from a user perspective, but from a management and administration perspective, it's a bit of a hassle. Yeah, it's a bit heavy. Mm. The screen isn't working. What? How? Wait, for real? Oh, it's not working on Discord? On YouTube is working. Okay. Well, if anyone's watching on Discord, actually, is that so? Martin, Kelly, who's House Jin? That's you. Okay. So it makes sense that it doesn't work because I think that I'm not 100% sure, but I think that only one process can reserve the video buffer outside of the monitor. And so because I started the YouTube broadcast first, it would make sense that Discord can't grab it. But I'm just going to kind of leave it for now. And if someone else comes in and starts complaining, then we can figure it out. But since everyone that's in Discord is here, I'm not going to worry about it. Is that all right? Cool. All right, so now I have to get my setup fixed again. There was something else. Right, this. This is the solved version. This is the original version. There we go. Okay. So moving forward, so cool. I've mentioned that continuous integration is a task runner. You're probably like, I don't know what the hell this means. The best way to explain it is to do it. Let's do it. So how do you do this? I'm glad you asked. Let's try it. So if you have your own project, we can kind of help walk you through it. But if you want to use an existing project, which honestly might be easier for managing the class, you can go ahead and clone down this repository here. Okay. And I'm going to give everyone a couple minutes to do that. If you want to follow along, you don't have to follow along, but it is an option. So I'm just going to wait a minute for people to do that. If anyone has trouble doing git clone for some reason, let me know. Yeah. You can go ahead and clone down this repository here. Okay. And I'm going to give everyone a couple minutes to do that. If you want to follow along, you don't have to follow along, but it is an option. So I'm just going to wait a minute for people to do that. If anyone has trouble doing git clone for some reason, let me know. I love this image. He looks absolutely insane. Yeah. Actually, you know what? Just to keep things smooth, if you've gotten to the point where you're ready to start working on this together, give me a signal. Like, just raise your hand or something. Oof. Rip. Mm. Yeah, we should have a good bit of we should have a good bit of extra time, so. Actually, you know what? Just to keep things smooth, if you've gotten to the point where you're ready to start working on this together, give me a signal. Like, just raise your hand. Oof. Rip. Mm. Yeah, we should have a good bit of we should have a good bit of extra time, so. Okay, so one's ready. Any others ready? Two's ready. 3, 4. Are the remaining people ready or not following along or still working on it? It is okay to not follow along if you don't want to, but if you do want to follow along, I want to make sure you're ready. Okay, so one's ready. Any others ready? Two's ready. Oh yeah, I should just share the repository in Discord. I'm sorry. That would be the smart thing to do. Where is it? Nope. Nope. Yep, here we go. Where is my repository? Where's my mouse? What the hell? I can't see my mouse. Yes, please. In the Saturday Hangouts channel. Thank you. Oh yeah, I should just share it. Ooh, why is my webcam quality so terrible? It doesn't really matter. Where is it? Nope. Nope. Yep, here we go. Where is my repository? Where's my mouse? What the hell? Thank you. All right, is anyone else still working on getting set up? You okay? You okay? Do you need help or are you okay? Okay. Martin. Okay. You okay? Okay. You okay? Cool. Whoops. Why did it go up over there? Come over here. That was weird. All right. All right, is anyone else still working on getting set up? You okay? You okay? Do you need help or are you okay? All right, so I'm going to assume that you folks are using Visual Studio Code. You okay? I'm personally not a fan, but that is what most people use, so I'm going to go with that. Why did it go up over there? We are going to set up a CI pipeline for this project. Okay. So what I'm going to assume that you folks are using Visual Studio Code. Sorry? I'm personally not a fan. No, I just realized I messed up. I shouldn't have asked you to clone this down. I should have asked you to fork the project first and then clone your fork. We are going to Yeah. Set up Yeah. a CI pipeline for this project. Yeah, but you'll have permissions and others won't. And I don't want to go through and get everyone's GitHub account and all that. So I'm sorry, folks. I messed up. Yeah. 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 So let me go ahead and let's do this. So go to github.com / yeah, my bad. So go here, okay? And then you could clone this down directly, and I did ask you to do that, but that was a mistake. I am so sorry. What you should do is click the big old fork button over here, okay? And that will fork it over to your personal account. All right, so I'm going to do that. Copy the main branch only. Yeah, copy the main branch only. I got to get rid of that plugin. Come on. Come on, you can do it. There we go. Okay, so now it's on my account. You can see the beach up here instead of CodeSoul. Okay. And then clone it down. And in which case I should actually fix my stuff. So I apologize for the confusion. I'm actually going to do a bit of nasty stuff here. Don't look at the man behind the curtain. Okay, so now it's on my account. You can see the beach up here instead of CodeSoul. Okay. Don't look at the man behind the curtain. You don't want to see what's going on here. I'm doing a terrible thing. Never, ever, ever do this. And in which case I should actually fix my stuff. Whoa, 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 whoa. Let me just make sure that's right. Yeah, that's right. Cool. Okay. Cool. All right. All right. So I apologize for the delay. Now does everyone have their fork, the project forked and cloned down? What's up, Jay? Oh, you're raising your hand for yes, you got it. My bad. All good. No. All right, so project should look like this. Is this big enough for everyone to see? Can you guys see this okay? Yeah, that's right. Cool. Okay. I'm gonna assume everyone has it cloned down. All right, so I apologize for and I'm gonna review the project briefly. So we got our standard README. There's not a whole lot in here. That's intentional. It's bad, but it's intentional. All right. We have. Oh. Does anyone not have Python installed on their computer? Python? No Python. I'm going to review the project briefly. We're going to have a fun time then. We got our standard README. There's not a whole lot in here. That's intentional. Yeah, but I'm going to do other stuff later. But yeah, for now, don't worry about it. Later. Oh, you have. Okay, great. Python 3 something? Does anyone not have Python installed on their computer? Oof. But okay, that's fine. All right, so let's do this then. So, right, we have a project here. I'm going to review it very briefly. I've already written a Docker file for you. All right, so that is not a Docker file. That's a Docker file. What the hell? What is going on? Okay. Anyway, I've written a Docker file here for you. Okay. You don't need to worry about it. I actually haven't tested it. Yeah, buddy.
And it's a backend API server. If you open up the source directory here, you got your main.py. It just does, this is copied directly from the Fast API tutorial. It's not anything special, it's not anything crazy. Okay? And then I wrote a tiny little test, also copied from the Fast API tutorial. The code doesn't actually matter, but we have a test here. It basically runs the server in test mode, or rather, it creates a testing client that simulates making a request to the API server. You know, it gets the main page, expects a 200, and expects this in the response body. Very simple, nothing fancy, nothing special. Requirements.txt, we're going to worry about that later. All good. Okay. So, actually, if you have Python installed, what I'm going to ask you to do is we're going to go through the setup together. Okay. And this is going to be a painful developer experience. And that's intentional. We'll make it better later. So let's do Python -m venv venv. Okay, so type that. This should work on Windows or Linux. I'm sorry, Windows or Mac. Actually, we got 2 Windows, 3 Windows, 3 Windows, 4 Macs. All right, yeah, so we'll have to support both. So run this. Okay. Yeah, I'm just going to leave it there for people to copy. We'll make it better later. So let's do Python -m venv venv. Okay, so type that. If you've done Python before, this should be no surprise. If you've not done Python before, please just bear with us. So you run this, and what this does is it creates a Python virtual environment, basically an isolated environment, in a directory called venv. So you will see here's a new directory, venv. Okay? So far, so good? If you've done Python before, this should be no surprise. Doop-a-doop-doop-doop. Please just bear with us. Doop-a-doop-doop-doop. So you run this, and what this does is it creates a Python virtual environment, basically an isolated environment. All good? In a directory called venv. So you will see here's a new directory. Do you need help? Okay. So far, so good? Yeah. This should work on both Linux and Windows. And then the next step is going to differ between Windows and Linux, but I'll show you both. But you got this written? All good? Do you need help? Yeah. Assuming that you're in the project directory. Yeah. Okay. So once you've done that, that should create that venv folder. Should be all good. Then if you're on Mac, do this. If you're on Windows, please wait. Okay. On Mac, do source venv bin activate. Whoa, activate. Okay. And you should see this little venv thing in the front. Okay, so if you're on Linux, do that. If you're on Windows, wait a second. Okay. We're doing like a mini Python workshop here, I guess. Do this. If you're on Windows, please wait. Okay. On Mac, do source venv bin activate. Whoa, activate. Okay. And you should see this little venv. Let me get my solution prepared here. If you're on Linux, do that. If you're on Windows, wait a second. Okay. Yeah, PyCharm would do it for you. Yeah. Okay. So when you in PyCharm, when you open up a new project, it's like, hey, do you want to make a virtual environment? And then if you just keep clicking OK, it'll do the right thing for you. Yeah, VS Code does not do any hand-holding. So let me get my solution prepared here. All right, so Mac people are good. All right, Windows people, you're gonna do something different. Yeah, PyCharm would do it for you. I need a moment. It's been a bit. You're going to do vm /scripts /activate.bat. Okay. Yeah. Okay. If you're on Windows, you're going to do that. All right. So Mac people are good. And then you're going to hit enter. All right. Windows people, you're going to do something different. And I really hope it works. I need a moment. That sounds right, actually. Can I see?
backslash scripts backslash activate.bat. Okay. Yeah. Okay. If you're on Windows, you're gonna do that, and then you're gonna hit enter. And I really hope it works. That sounds right, actually. Can I see? If you do your VM creation in, yeah, because then it's going to use, well, and you have to have Python installed in that bash. Yeah. Actually, I'm not sure. It depends on which way you're doing bash, because there's a bash for Windows, which is weird. Yeah, but does it do like a Windows bash, or does it do like a Cygwin thing? Because then it's going to use, well, and you have to have Python installed in that bash. Yeah. Actually, I'm not sure. It depends on which way you're doing bash, because there's a bash for Windows, which is weird. No idea. Would need to test. Yeah. All right. So is everyone good? Everyone got to this point? Yeah, but does it? What's up? Still? All right. Let me come over. Check it out. No idea. Would need to test. Yeah. All right. So is everyone good? Everyone got to this point? What's up? Still? All right. Let me come over. Check it out. Well, in any case, while you're getting set up, we're going to go forward because you don't actually need to pick up the show. So, going forward, we just want to check to make sure that everything is okay, right? So we can do, so first off, we need to install the dependencies, right? We're using Fast API. It's a framework. We have to install it from the internet, right? So to do that, we can use pip. We can do python m pip install. Okay. This will install dependencies. We can do -r requirements. Requirements.txt and requirements. Whoops. And then -r again. Requirements.dev.txt. All right, that will install the production dependencies and the development dependencies. Okay. So you can do that. Now I already installed the stuff, so it just went instantly for me. But yours is going to take a minute. And I'll bring up the command again. It's this one down here at the bottom. Actually, you know what? You guys are on Discord. Let me just share this in Discord. I am so dumb. Huh? What's that? Yeah. So you're going to do that. Whoa, typing is hard. Okay. Copy and paste is our friend. All right, so everyone's got that running. It's downloading dependencies, all that good stuff. Cool. Yeah. So you're gonna do that. Whoa, typing is hard. Okay. Copy and paste is our friend. Good. All right, so everyone's got that running. It's downloading dependencies, all that good stuff. Good. Cool. All right. So that's all good, right? And now we should be able to do. Let me check my history. No. Yeah. So this is a complicated command. I'm just going to copy and paste this to you guys. All right. So that's all good, right? And now. Okay. So you should get something like this. It should run. Okay. I pasted the command in Discord.
And then if you go to your browser and you go to localhost colon 8000, you should see that. Okay. So you should get something like this. It should run. Okay. I pasted the command in Discord. Everything's in Discord. It's in the Saturday Hangouts channel. So on the left side, you have all the channels. You can scroll down. There's under groups, there's one called Saturday Hangouts. You can just copy from there. Oh no. Yeah. Everything's in Discord. It's in the Saturday Hangouts channel. So on the left side, you have all the channels. You can scroll down. There's under groups, there's one called Saturday Hangouts. You can just copy from there. This is the trouble of doing things not in Docker. No, there's a FCNTL, something like that. No, it's a fast API thing. Oh. Wow. Nope, I'm using Linux. Well then. No, there's a FCNTL, something like that. Yeah. Yeah. Wow. That's annoying. Well, then in that case. Nope, I'm using Linux. Yeah, that's a good idea. Yeah, so you're not going to be able to run it. I wonder, can we do? That's annoying. Well, then in that case. Haha. Yeah, that's a good idea. Yeah, so you're not going to be able to run it. Give me a moment. I wonder, can we do? Give me a second. What? Oh, right. Hey, there we go. Okay. You should be able to run this instead. So try this. Give me a second. I sent a thing in Discord. You can just copy that. What? Oh, right. Hey, there we go. Okay. All right, are Windows folks able to get that to work? So yeah? All right. Can you visit that local host in your browser and you see it? It's all good? I sent a thing in Discord. You can just copy that. Cool. All right. Kelly, how about you? All right, are Windows folks able to get that to work? Yep. Yeah? All right. Can you visit that local host in your browser and you see it? It's all good? How about you two? All right, let me go check you guys out real quick. Cool. All right. check you guys out real quick. Sorry for the delay, everyone, but it seems everyone's caught up now. So I have to establish context again. What am I doing? Why did we do this? Why did we do this? Right. So if you can do that, that means your project is set up correctly. So we're going to do continuous integration. Continuous integration involves testing. So we should run our tests, make sure that our tests work. So I've already configured testing here. If you look in pytest.ini, I've configured it to work with our source directory stuff. So that's all fine. You shouldn't have to change anything. All right. You should be able to just do Python m pytest. Wait, haha. Yep, thank you. Oh my god. No, I want Control D. There we go. I cannot type while looking in the opposite direction. All right, so if you do that, it should find test main.py, it should run the test, it should pass, everything is cool. Everyone can do this? Great. Now, imagine this is an actual project, right? And imagine you have a whole team and you have hundreds of tests, okay? Because your team is good, you have like 80, 90 something percent test coverage. How do we get our tests to run anytime that someone wants to merge code? So that we make sure that if someone tries to merge their code with ours, that the tests pass first. Okay? So what we're going to do is we're going to make a new directory. Okay, so you can just click this new folder button here. Actually, let me delete mine so I can walk through it with you. Okay, so click in the empty space, click this new folder here, and do .github. Okay, we're going to do GitHub Actions. Okay, we're going to do GitHub's CI. So make a new folder called .github. All right. And then inside that, I have to look at my solution because I don't remember. Where's my solution? There it is. Inside that, click the new folder again and make a folder called Workflows. Okay? So far, so good. .github and then workflows. That dot in front of GitHub is important. What's up? Directory, yes. And it should look something like this. Good. So now, wait, you said you had to go at 7, right? Are you okay? Okay, we're gonna go fast. So now, make a new file this time, and let's call this file tests.yaml. Okay? And then that's gonna make a new file here for us to do stuff with. All right? And it should be in our GitHub workflows folder. So far, so good? Good. All right, now I'm gonna dump a whole bunch of stuff at you because we have to go fast now. So rather than ask you to type all this stuff with me, we're just gonna do copy paste. All right. All right, I copied it in Discord. If you look in Discord, you can just copy this down. Okay. So what is this doing? I should probably make it so that you can actually see the whole thing. There we go. So we are making a new workflow called tests. Okay. When do we run this workflow? We run it on some event. That event is a pull request. I'm just literally walking through this. All right. And it's a pull request only for specific branches. And that specific branch is for the main branch. Okay? So basically, this workflow will only trigger when there's a pull request for the main branch. Does anyone not know what a pull request is? Does anyone not know what a branch is? Actually, if you understand what a pull request is, you understand what a branch is. So we're good. So that's the condition that triggers our workflow. Okay? Next, we define the jobs, basically the things we're going to do, as part of our workflow. Okay? So we have to build our workflow. Okay? And then we need to tell it what infrastructure should this run on. Should this run on Windows? Should this run on Linux? Should this run on Mac? For purposes of ease, we're going to run this on a Linux Ubuntu environment. Okay, so that's what this says. Run it on Ubuntu. All right. And then we have the steps, the things we actually want to do. First, we need to check out the repository. Okay. Second, we need to set up Python. Third, we need to install our dependencies. And fourth, we need to run our tests. Okay? Does that make logical sense to everyone? I'm going to break down what the syntax means in a second. Okay? So you see this name checkout actions or uses actions checkout v3. What the hell does that mean? Right? Name is name. You're probably good with that. Right? It's just a label. This can be whatever you want. You can call it monkey butts, right? It doesn't matter. Okay? I'm not going to actually call it monkey butts. And then this, rather than write a whole bunch of code ourselves, GitHub has provided a whole bunch of code for us, just like a library. This is basically an import. So if you go to the interwebs and you search for GitHub Actions Checkout, you will see this repository actions/checkout, and it's an action for where's the description? Action for checking out a repo, right? And this is just a repository on GitHub, and they show you how to use it. Okay? So this just checks out the repository. Why does it check out the repository? I thought we were already in Git, right? Not quite. So when it says runs on Ubuntu latest, what GitHub will actually do is it'll create a new Docker container using the Ubuntu latest image, which is just raw Ubuntu. There's nothing on there. Okay? So we need to tell that Docker image, hey, check out our code. Okay? Then we need to tell it, hey, set up Python. This is just another action. If you Google for GitHub Actions set up Python, this will come up. That's actually how I found it. Okay? And then you specify a Python version. In this case, I want to run 3.10. I know 3.11 is out, but PyTorch is not on 3.11, so I'm not ready. I'm not ready yet. And then we install our dependencies just like we did on your local machine earlier, right? So basically, your process of setting up your environment on your computer, you also need to do on here, okay? So you clone down the code from GitHub. You set up Python on your computer, ideally in the past. You installed the dependencies, and then you run the test. Okay? That is what you normally do to test your code before you share it with other people, right? You set things up, you test. Same thing with CI. Okay? Does that make sense? So this is not a script. This is YAML. YAML is just a data format like JSON or CSV or whatever, right? So it doesn't, you can't run this, it's not executable. But when you commit this to Git and you push it up to GitHub, GitHub will read this and then it will parse it and do all the stuff. So let's go ahead and try it. Go ahead and now with this change, you know, git status, do normal git stuff, right? So if you do git status, you know, you see one file or one directory changed, git add .github, right? Oh my god, I cannot type. Okay, then we see, right, see, then we see, okay, we added this new file, right, standard stuff, git commit, see you next time. And then we can say, I'm following conventional commits, added testing workflow, okay? So we can commit that. So far so good. And then git push. Okay, so far so good. Is anyone having git troubles? Let me take a look. So far so good. Is anyone having git troubles? Let me take a look. Yeah, so do git push down. Actually, wait. Yeah, what? What did that? No one else hit an error when they pushed, right? Did anyone else hit an error when they pushed? He might have used it. Hold up. GitHub auth HTTP clone. There's got to be a way to do this. What? Yeah. Well, but then if they're on Windows, they have to set up their SSH key and all that junk. Oh, HTTPS OAuth 2. OAuth key goes here. Hold up. That seems gross. GitHub auth HTTP clone. There's got to be a way to do this. No. What? They can just update their config. Yeah. Well, but then if they're on Windows, they have to set up their SSH key and all that junk. Oh, HTTPS. Yeah. Man. Key goes here. That seems gross. Maybe. All right. You know what? Let's just do Windows generate SSH token. They can just update their config. Git configure SSH token Windows. Yeah. Man. Oh, look at that. Oh. Ooh, Windows got fancy. Okay. So, I'm going to share these two tutorials. Our Mac folks, I'm sorry. Thank you for your patience. So follow these two tutorials. Let me make sure that this is... No, she was having the same trouble. Okay. So, I'm going to share these two tutorials. Okay. Mac folks, I'm sorry. Thank you for your patience. Okay. So follow these two tutorials. Yeah. So these tutorials should be pretty fast. Yeah, but in the interest of time, we have to move forward. Is that okay? All right. So now, if you go back to your GitHub, right, you should see this new GitHub workflows. That's all good, right? Oh, I didn't actually test this part. I don't know if this is going to work. We're going to find out. It's going to be great. So you'll see that this branch is one commit ahead of code soul main. And then what you'll want to do... I actually don't... sync fork? Contribute. There we go. You want to click this contribute button here. They changed the UI. And then click open pull request. God, I really hope this works. And then normally you'd want to, fill out all sorts of nice information here, right? And hit create pull request. And then what you'll want to do... There we go. Whew. Okay. Whew. I was really worried that wasn't going to work. Now, this is the cool part. That .github/workflows/tests.yaml file that you made this little yellow box happen. What happened was, remember we said that the trigger was on pull request to the main branch. This is now a pull request to the main branch of the original project that you guys forked. Okay? So what happened was, GitHub, it had this pull request come in, it looked through the workflows, it saw this trigger, and it's like, oh, I guess I should do this now. And this green box now here is what it did. So if we click show all checks, you see that, remember this tests thing? Right? We called it tests by name. If you click details, remember how we did the checkout, set up Python, install dependencies, run tests? That's everything we defined in our YAML file. Okay? So we see it checked out the project. Okay? It set up Python, installed our dependencies. You can see here's all the pip stuff that you saw earlier when you ran it locally, right? And then it ran our tests. We got that one test pass. Okay? So now, if we merge this, all right, anytime someone makes a pull request, this is going to happen again. And if any of these fail, if any step fails, This nice green box is going to be a red box. And that will warn the other engineers on your team, hey, this code is broken. Don't merge it. Okay? This, sorry? Remember in our project here, we said it runs on Ubuntu latest? GitHub, in their cloudy stuff, they just set up a Docker container with Ubuntu and then ran all this stuff inside it. Okay, does that make sense? So in this way, you can automatically run tests every time someone merges code, regardless of whether or not they ran tests themselves, because you can't control their computer, but you can control GitHub. Okay, does that make sense? Cool. Does everyone understand how and why this is useful? Okay, I think people are a little burned out on fixing environment issues. So let's go back to the presentation then. All right. Oh man, I got to do all this junk again. Give me a bigger screen. I can't read. Oh god. Okay. So cool. We did continuous integration. Good job, folks. You ran your first tests in continuous integration. Now, GitHub Actions are not the only way to do it. That's just the easiest way to get it set up with this. Okay. But after continuous integration, once you've made sure, like, hey, all of our code gets tested on merge, all of our code has all these checks that we want to do, right? Next, you want to do continuous delivery. Okay? Continuous delivery, often abbreviated as CD. It's whereas CI is like very much like, hey, you write this code to do CI, right? CD is not as direct. It's more like a general set of practices. Now there is some code you want to write, but that's not the core part of continuous delivery. If you're doing continuous delivery properly, you're going to change the way that you run your projects. Okay? Rather than have like one release every 6 months, right? You're going to do frequent releases, maybe every 2 weeks. Now, does that mean you're releasing your product to customers every 2 weeks? No, it does not. You do not have to do that. But you should release to some stable production-like environment every 2 weeks and have people testing that and experimenting on it and this kind of stuff. Okay? Now, this means you have automatic deploys. Once that pull request gets accepted, right, it's going to automatically deploy it to your environment. Okay? That's how it should work. All right? So that's also why you want to keep your changes small. Smaller changes, smaller, more frequent changes are less likely to break. Your code is going to be more stable. When you make big changes, there's a higher likelihood of bugs. There's a higher likelihood that someone missed something during review. There's a higher likelihood that a test is missing. Okay? If you do smaller things, our stupid little monkey brains, right? We only have so much attention, right? A smaller code change is going to be easier for us to understand than a big giant one, all right? Another thing about CD is you should have strong monitoring. If you do an automated release of your software and something's wrong, and you don't have monitoring, you won't know something's wrong. Okay, so you need monitoring set up in order to see that there are problems and then be able to react to them. Okay? Additionally, if you are releasing to customers directly, which actually is the recommended way if you can. Now, if you're at like a bank or if you're at like a medical company or something, you can't actually release to customers directly because you have to go through a whole bunch of regulatory stuff, which is why I mentioned you can deploy to a production-like internal environment. But if you can deploy to customers directly, you should, which sounds scary, but again, if you make tiny releases, it's not so bad. And you can have multiple production environments, right? So let's say you're serving 100 users, right? And you split up your environment where 80% of users go to this deployment and 20% of users go to this deployment, right? What you do is you release your code to the smaller environment. Now they're both being served to production, right? Users are accessing both of these, right? You do a deploy to the smaller one, and then you watch your monitoring, okay? If you see all the monitoring lights go off, you're like, oh shit, but we only impacted 20% of users. Okay, and then you roll back, right? If things go well, then you say, okay, now this one is the main one. You grow this to 80%, you shrink the other one to 20%, right? Or whatever. And eventually then you copy the release over to the other one so you have both running the same version. Okay, but basically, when you're doing proper continuous delivery, you release your, I'm sorry, when you're doing, this is called blue-green deployment. When you're doing blue-green deployment, you deploy to one of the environments, either blue or green, okay? And then you kind of watch and test to make sure that it's only impacting a subset of users. If everything is good, then you also deploy it to the other environment, okay? Now, the thing about all of this is a big, big, big change. Most people don't like doing things this way. It sounds terrifying, right? So it requires a big cultural, organizational, and perspective change, okay? Your company needs to be comfortable with making frequent changes and being comfortable with saying, hey, we made a deploy, it messed up, we roll back, all right? You don't have someone being like, oh, no, I can fix it, let me hot fix it. No, you roll back. Go back through the development cycle, deploy again. But if you're doing continuous delivery, your deployment cycles should, or your development cycles should be really short anyway, right? So rolling back and then going and fixing the development shouldn't be a big deal, okay? Continuous delivery, small and fast, okay? Now, another thing, it requires very strong testing discipline. You have to have good tests, because otherwise you're releasing untested code all the time, right? And that's a terrible idea, okay? And then you also need good planning. Because if you don't plan things properly, if you don't have an architect going through and designing everything out in some amount of detail, honestly, I'll just share it. You don't need to copy it down. It is in the repository, which I'll share later. But basically, and this is not a blue-green deployment. This is not a proper thing. But let me grab my. Okay, we're getting a little tight on time now. So basically, what you would do, remember how our CI, I mentioned that CI tools are just task runners? You can use them to do continuous delivery tasks, right? So what you can do is just, make a new file, and let's call this deploy.yaml, right? And then I can copy a whole bunch of stuff in it. You don't need to follow along with this, right? And then this basically says, check out the repository again, and this time, do a Docker build. Okay, now this is really simple, right? All these GitHub actions exist so that we don't have to write a whole bunch of custom code. You just say, hey, the Docker file is in the root project directory. In this case, you would want to push it, right? And then, we would tag it as codesol DevOps or Dummies latest, and then push it to Docker Hub. And then you might have another one of like, name, wait, hold up. Yeah, name, deploy, and then you would have something like run. You could do, if you're doing Kubernetes, you could do Helm. Oh my God, I haven't written Helm stuff directly in a really long time. Because you do it once and then you're like, oh, I never did need to do this again. I guess Helm upgrade my app, some release name, prod namespace. I don't know. I'm just making that up. I don't know what the Helm command looks like, but and then you run some script to deploy your app, right? Does that make sense? Now, this is actually not a perfect example, because in reality, what we would probably want to do is part of our testing, we'd actually want to build the Docker container and then push it with a dev tag and then run our tests against the built Docker container, because that's our production environment. Because that that Docker image is what's going to go to production, so that's what you want to test. But in any case, you would basically just include the steps to do your deployment in your CI as a separate workflow. And then you would have it work on a separate event, basically when you do a release. Okay? Because in GitHub, you can always create a new release, and you could say, tag version 1.0.0, and it does stuff and whatever, and then you can say publish release, and then when you do that, it would trigger that workflow. Does that make sense? Questions? Go back to the code here. Sorry that this example is not perfect. We're getting tight on time. All right, so let's move forward then. This is a version of this is in the main repository, so but I'll show you at the end. So you don't need to copy. Don't be like frantically trying to copy this down. It's shared later. Okay. So then let's go back to the presentation. So we mentioned that continuous delivery, if you want to do a good job of it, you want strong monitoring, right? So let's go ahead and talk about monitoring. Monitoring is basically how do you know when the application is down? If shit's broken, how do you know that stuff's on fire and how do you go fix it? You can do better than Cacao, I bet. So there are different types of monitoring. Now, this is not an official list of groupings, okay? If you ask different people, they will give you different answers. This is just how I group the types of monitoring, all right? So you have infrastructure monitoring, which is like, is the server on? How are the CPU? How are memory? How are disk? Application, actually, I'm not going to go into the details. Application performance monitoring, which is how is the application performing? Pretty standard. Logging, right? Because your application should be writing out text of events and interesting things or warnings or errors that happen. And then security information and event management. So basically, how do you know if someone has hacked into your stuff, or how do you know if someone unusual has access to your network? And then synthetic transaction monitoring, like basically running fake traffic through your application to see how it responds. Now, this may or may not be necessary, that last one. I'm a fan of it, but yeah. So breaking this down, these different areas of monitoring cover different data. So infrastructure is CPU, memory, disk, and whether the server's turned on, right? Application is the application up and running, right? What's the response time? If it gets a request, does it respond within 1 second or a few hundred milliseconds or whatever? Are there errors? How many? Where do they come from? Logging, basically, where did the log come from? And then have some structure of the log, right? So the log might have like request origin, status code, log message, endpoint, whatever, right? Just normal application logging. And then security is like, where did the request come from, right? Because if your traffic serves Korea, but then you have a whole bunch of requests from Russia or the US or Latin America or something, you might be like, wait, why am I getting this traffic? Is someone trying to break into my shit? Request rate. Basically, given some origin, are they making a whole bunch of requests in a short time? Are they trying to attack you and just overload your system? You want to know that. And then uncommon requests, right? You should have some kind of profile of what your normal requests are. And most security software can create these kind of common profiles for you. And then when you get traffic that doesn't match that profile, it can be like, wait, whoa, this is weird. I should alert you about this. Okay. And then synthetic transactions is mostly the same as APM. It's just that you can control the traffic and you define what transactions and you know exactly what happened, whereas user behavior is all kinds of funky and weird and difficult to isolate. Okay. Questions about the different kinds of data that you should be monitoring? Cool. So then, what kind of tools are there? Prometheus and Grafana, if you're doing stuff on Kubernetes, that's pretty much the way to go. Okay. Prometheus is a very standard metrics collection system. Grafana is just a graphing and visualization tool. So you set up Prometheus to get the data, you put Grafana on top of it so you can see the data. That's all that is. Okay. But if you don't want to manage the stuff yourselves, or you're not on Kubernetes, or whatever, there are all sorts of other options. So there's like App Dynamics, which is an APM solution. Sentry, also an APM solution, but I think they also do logging. Not 100% sure. Datadog does logging and availability and application performance monitoring. And then Elastic, I don't know why I put Elastic APM, because Elastic, yeah, I should have just put the whole Elastic Stack. The Elastic Stack does logging, security, APM. You can kind of do infrastructure with it. It can do everything, but it's a bit tricky to set up. Now, these are not the only tools. This is just stuff that you can go look into. You can look up alternatives for all these. I just thought I'd put some of these on here for you to investigate if you're looking for a monitoring solution now. Okay, does that make sense? Cool. So, oh geez, yeah, I don't know if we have time to try this. Yeah, we're not gonna have time to try this. We only have 15 minutes, and just getting it up and running is going to take 15 minutes. But I guess that's pretty much. Yeah. So we're gonna skip this for now. I'll write up a bit of a tutorial. Actually, no. I will share the tutorial that I was gonna follow to do this, right? Because I didn't write my own tutorial. I was just following theirs. Um, and I'll share it with you guys on Discord. Yeah, because we don't have enough time now. So, last section is developer experience. This is kind of the lowest priority for DevOps, but if you want the team to like you, you can do this. It'll make them super happy. So, developer experience is like the complexity and effort required to do development, right? If you have a new person come to your team, right, and they got a brand new computer, how much time does it take them to get set up? How much time does it take them to set up a new project, right? Developer experience is trying to solve these kinds of things. If I'm a front end engineer, right, and back end just release something, right, and maybe we don't have a shared dev environment, can I run the stuff locally, right? Can I just pull backend's code, run it on my machine, and test my front end against the back end, right? Or um, maybe my feature relies on one of backend's features, which is not yet merged, but they have their stuff in Git. I could just clone their stuff down, and even though it's not merged yet, and I can just test their feature against mine, right? These kinds of things. So, how many steps does it take to set up your environment? How about to run the software? How about the tests? How can we control the quality of our code? These are the kinds of things you think about when preparing developer experience. And then there's other automation as well. So like having a good README is kind of like automating people because they're just going to go through the README and they're just going to copy and paste everything, right? Also, easy configuration management, right? If you have secrets that you need to share with your team, how do you make that easy, right? Because secrets, they have to be secure. Security usually makes more effort, but you want to try to figure out a way to make it easy for your team, right? And then there's other stuff like linting, formatting, make files, npm scripts, other toolchain stuff, okay? So let's go ahead and, oh, right, sorry. So a key example of setting up a development environment, there's this project here. We actually used a modified version of it on my team. It is, remember how I said you can use Ansible to set up data centers, right? Ansible just configures any computer. If it can run Python, you can configure it with Ansible. And anything can run Python once you install it. So, my team actually basically cloned this guy's thing, where when a new engineer comes on the team, they can start coding that day. Which, like, if you talk to some people in the industry, they're like, how? What is this black magic witchery you speak of, right? We just have an Ansible playbook, right? They just clone it down, right? Because Mac comes with Git installed already, I think. Or you just do the Xcode utilities install, which is just a one-line command. And then, they clone down the repository. They hit Ansible Go, right? Or Ansible Run Playbook, whatever. And then installs Visual Code Studio, installs PyCharm, it upgrades Git, it installs, SQL tools, it installs, the Chrome browser, it installs everything, right? And it's just one command, and their whole system is set up. Because usually it takes engineers like a couple of days to get their machine just right. But if you have a standard workflow that your team uses, throw it in an Ansible playbook, put it in a repository, and be like, hey, clone this down, run it, you're good to go.
they can start coding that day. Does that make sense? So, um, so you could accomplish a similar thing with Docker, but it acts a little bit differently. You could actually do both of these. So she was asking, I heard you can do a similar thing with Docker, right? So what you could do is for each project, you could set up a kind of standard Docker image for your team that has all the tools installed already, but that's only like libraries and stuff. That's not so much like, having a GUI tool for browsing the database. That's not going to be in a Docker image, right? Or having like Slack is not going to be in a Docker image, right? Um, and you wouldn't want to run that inside a Docker container anyway, because it has a UI component, right? So with Ansible, you can be like, hey, let me install Slack, let me install our secret management tool, let me install Chrome, all this kind of stuff. Does that make sense? Cool. Yeah, yeah, it works on Windows. Mm. I mean, a shell script works too, right? Like whatever works. If you know Bash and you don't know Ansible, just do it with Bash, right? Um, it's quite nice. So like, if we look at our main.yaml here, he does some configuration. He sets up the OSX command line tools because you need that to do anything. He sets up Homebrew, which is a package manager for Mac. And then he installs some stuff that's not in Homebrew. He configures his dock for his notebook. That's pretty cool, actually. He sets up permissions. He configures his terminal. He does operating system level configurations. He uses Sublime Text, really? Okay. Weird, but all right. More power to him. And then all that is defined in these tasks. So he has some. Nope, nope. Where is it? Where is it? Files. I just went there though. Yeah. I'm looking for. No, no, that's Sublime. Where? Am I dumb? Hold up. Let me look at this. Where's his? Where's his? I don't know where it is. But in any case. Oh, I'm dumb. It's right there. What? What? All right. I don't know how his stuff is configured because I haven't done Ansible in a really long time. There we go. So install npm, install pip, install Ruby, this kind of stuff. Okay. I feel like there's a bunch of stuff missing. Default config? Yeah, here we go. So like, here's all of the homebrew packages he installs, right? So he just says, hey, Ansible, install homebrew, install all these homebrew packages, and then homebrew installs all the software that he uses on his computer. I guess so. I mean, he's got a whole bunch of languages here, though. And then he also has his cast stuff, so he installs Docker, installs Dropbox, his browsers, everything. You can set up a whole computer this way. He installs Slack, all that good stuff. Okay? So this is like a big developer experience thing. It also makes sure that all your engineers are running the same environment. Yeah, it's nice. Yeah. So given that, that's not the only way. Ansible's not the only way to do things. Let's go ahead and let me just make sure. Yeah. Okay. So this is the last section, and we have 5 minutes. So I'm just going to show you guys how this works. So actually, let me just show you the solved version. So this is a very, very simple implementation of it, but so I set up a make file. Make is usually used with C, but it's just like a script to run tasks, right? So you can use it for whatever. And it's been around for a long time, so you know it works, right? So what I do here is I say, now you would have to install CMake on your machine, so we're not going to do this together. But you could basically, if I open up my terminal here, Why is it? Okay. What? Dude? Windows. Oh, I just need to change the default. Yeah, okay. So I could just do make. So rather than like, remember how we had to set up the environment? We had to, well, we didn't upgrade pip, but we had to install all this stuff, right? Rather than do all these one by one and remember what all of them are, if you, with your team, say, hey, every project's going to have a make file, every make file is going to have a setup command. If you just do make setup, it sets up the project for you. That makes things way easier for everyone. Someone can onboard into a new project in minutes. So I can just do make setup. Done. And then it updates pip. It installs dependencies. And then it installs. Well, it would install pre-commit if I did not suck. I must have missed it in my. Oh, I know why. No, 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 no. This is why testing is important, boys and girls. What? Oh. Fine. Be that way. Whoops. Man, C is really finicky. Or make is really finicky. There we go. Now this is like bashy or this is like Linuxy stuff. On Windows it would be different. You need to go learn the Windows equivalents. But basically, this is just a way to group a whole bunch of commands into a single command, right? And then rather than remember how we had all this big giant long thing of bullshit, right? You're not going to memorize all that. There's no reason for you to memorize all that. Make run. Bro. Oh. Yeah. There's a way to there's a way to do this automatically with make too. I just didn't know how. So now make run. Bam. Okay? Way simpler, right? So that's one thing. So that's in terms of developer experience, making things smooth, making things easy. Now, my department, every project, every Python project has a make file. Every JavaScript project has npm scripts to set up this kind of stuff. Okay? Keep it simple, keep it easy. And then you might be wondering, hey, what is all this pre-commit stuff? Let's say that you have coding conventions, right? For example, there's specific formats that you follow, right? Specific code formats, or if you're running Python, there's PEP 8, right? Basically the standard way to format code. Or maybe you want to do static type analysis or whatever. There's a tool called pre-commit, which allows you to specify, hey, before the user commits a change, check this shit. If any of these checks fail, they can't commit. Okay? Now that's great because that forces them to make sure their code meets a certain level of quality. Pre-commit is often used with Python projects. You can use it with other projects as well. Okay? If you go to the pre-commit website, they have a list of which languages it works with. Okay? However, if you're using JavaScript, Node.js, I recommend instead using Husky. It does the same thing. Husky, Husky, like the dog, does the same thing. And then Go does all this for you, so you don't need to worry about it. And the other languages I'm not as good with. So basically, if I introduced, so let's say that I went into my main and I introduced an unnecessary import, right? I'm importing JSON. I'm not using JSON, right? There's no reason for this to be in my code. And then let's say get status, cool, get add a, get commit, stuff. What happens is pre-commit recognizes that it's set up. It downloads all the dependencies because it needs code to do all these checks, right? So it installs all that stuff. And it notices, hey, you tried to import JSON, but you're not using it. Fix that. Okay? So it makes sure that your stuff is good. So now I remove this. Git add everything. Git commit. What is it? Let's say chore fixed makefile VM. No, fixed makefile pre-commit setup. There we go. Okay. And then I'm just going to push because yeah. Okay. Does that make sense? Questions, comments, ideas? Now, formatting is not the only thing you can do here. You could also have pre-commit run unit tests, right? You would not want to run integration tests because those are too slow, but you could run unit tests. They should only take 1 or 2 seconds. Basically anything to make your code consistent and to make sure your commits are of high quality. You can also do stuff like if you're using conventional commits for your commit messages, it can check that kind of stuff. If you want to check for duplicate code, all these kinds of things. All right. So I apologize that we ended up being a bit tight on time, but any questions before we end? Just generally? So for benefit of the stream, are there any things other than pre-commit that developers should set up locally? Um, uh, Also, thank you, Chipintino. I don't know who you are, but thank you for watching. Huh? That's you. Cool. We have 1 viewer on YouTube. Other tools. Um, Actually, yes. So if you're on Mac, you should be using ZSH. ZSH has a whole giant host of plugins. One of my favorite plugins is called The Fuck, because if sometimes you're typing really fast and you have a typo in a command, right? And it's off by 1 character. Maybe instead of typing git, you type GTI, right? And then you have a really long commit message, right? And you're like, man, I don't want to type all that again, or I don't want to hit the up key and then go back to the beginning of the line and all this stuff, right? You just want it fixed. Well, if you install The Fuck and you make a mistake, you just type fuck and hit enter, and it'll be like, did you mean this? And you just hit enter again, and it'll fix it for you. One of my favorites. Huh? No, that's the name of the command, fuck. It's great. Yeah. There's also, but the project is called The Fuck, all 1 word. Because otherwise, if you just search fuck, you're going to find stuff you don't want to see. Yeah, it's on GitHub. There's also, there's also another one called ASDF. So for example, there's a whole bunch of different, Python, you have Python 3.7, 3.8, 3.10, 3.11, 3.9. NPM, you have so many versions. You have all these different versions of software. And then like you have PyEnv, you have, NPM environment or Node environment manager, RubyEnv, all these different environment. Man, screw all that shit. ASDF is an alternatives manager for all of the software. All right? So you can just do ASDF Python local 3.8. And that will set the Python version for the local directory to 3.8. And then you're good. And you can say, oh, I don't have Python 3.11. ASDF, install Python 3.11. Done. GG easy, right? ASDF is great. I've considered it. I think that the updates to pip plus the pyproject.toml solves a lot of the similar problems. Not all of them, because it doesn't do version locking like poetry does. So I'm still kind of on the fence about whether to do poetry or pyproject. Yeah, we're considering, but we haven't decided yet. We have other stuff we're trying to figure out first. Other tools. I think that's it. tell you what, later I'll go ahead and I'll add an appendix to the presentation. Uh, so that I mentioned how we have that script to automate all of our machine setup. We have a whole bunch of tools in there. I'll just look through that and I'll pull out the good ones and I'll toss them in the presentation. Yeah. All right. Any other questions before we end? Cool. All right. Well, thank you very much, everyone. I hope you had a good time. I apologize for all the trouble. We got to figure out a better way to do to do interactive workshops because the environment setup is a pain. We'll probably do a little bit more. There's the prerequisites section. We'll probably spend a little bit of time like, hey, here's a quick little web page or like a GitHub gist or something like this has to be set this way, this has to be set this way, and this way you can make sure your environment is set up before we come to the event, and that just save us a bunch of time. So I'll start doing that from now on because developer experience. So yeah. All right. Well, thank you again, everyone, and we'll hope to see you next time. For those of you who are here today, let's go eat. Bye, YouTube.